The rain begins to fall, yet the glass in front of you stays perfectly clear. In a world where dust covers everything, this surface seems to defy nature itself. This is not magic, and it is not science fiction. It is the silent revolution of self-cleaning glass. A technology designed to fight one of humanity's oldest maintenance problems. And its impact may be far bigger than you think. But to understand why it matters, we must first look at the dirt. Because dirt is not just ugly, it is expensive. And sometimes it is even dangerous. This is the hidden story behind a transparent invention. Modern cities are built on glass. Towers rise higher every year, turning windows into vertical oceans of transparency. Yet every surface attracts dust, pollution, and organic residue. Rainwater leaves mineral stains that slowly destroy clarity. Sunlight makes the problem worse by baking contaminants onto the surface. Cleaning becomes a constant, repetitive battle. In megacities, millions are spent every year just to keep windows shining. For skyscrapers, the task requires specialized teams and extreme logistics. Even small homes struggle with constant cleaning routines. Humanity needed a smarter solution. The breakthrough began with a simple observation in nature. Scientists noticed how rain washed dirt away effortlessly. This phenomenon inspired engineers to rethink glass entirely. What if windows could clean themselves the same way? The idea sounded radical at first, but material science was entering a new era. Researchers began experimenting with microscopic coatings. Failures came first, and they came often. Yet persistence slowly turned concept into reality. The self-cleaning revolution had officially begun. At the heart of self-cleaning glass lies a thin, invisible coating. This coating is often made from titanium dioxide. Under sunlight, it triggers a powerful chemical reaction. Organic dirt begins to break down at a molecular level. This process is known as photocatalysis. But that is only half of the story. The coating also makes the surface superhydrophilic. Instead of forming droplets, rain creates a thin cleaning film. Dirt residues are washed away without streaks. The result is a window that maintains clarity with minimal effort. Invisible chemistry is quietly doing the hard work. Technology becomes almost poetic in its simplicity. And yet its engineering precision is extraordinary. Billions of microscopic reactions happen every second, all to keep a surface looking effortlessly clean. Today, self-cleaning glass is transforming architecture. Large facades can now remain transparent for longer periods. Maintenance costs are significantly reduced. Solar panels also benefit from cleaner surfaces. More light means more energy production. Greenhouses use it to maximize plant growth. Transportation industries are beginning to adopt it too. Even residential homes are entering this new era. What was once experimental is becoming mainstream. And the pace of innovation is accelerating. Some modern towers contain over 100,000 glass panels. Cleaning them manually can take weeks. Self-cleaning coatings can dramatically reduce these cycles. This translates into huge financial savings worldwide. It also reduces water consumption for cleaning operations. Environmental benefits are quietly accumulating. Cities become brighter as natural light increases indoors. Productivity and well-being may even improve. Sometimes the smallest surface innovations create massive systemic change. Transparent technology can reshape invisible economies. Yet self-cleaning glass is not perfect. It still relies on sunlight to activate its chemistry. In very dry climates, rain may not arrive often enough. Certain types of dirt remain difficult to remove. Initial installation costs can also be higher, and coatings can degrade slowly over time. Engineers continue working to improve durability. The next generation may be even smarter. Innovation never truly stands still, especially when the stakes are global. Urban populations are growing at unprecedented speed. Buildings must become more efficient and sustainable. Self-cleaning glass supports this silent transformation. It reduces resource use without changing daily habits. Technology becomes invisible when it works best. The future of cities may depend on such quiet innovations. Surfaces will not just protect us, they will serve us. Windows may soon become active technological systems. The boundary between architecture and engineering is fading, and transparency itself is being reinvented. Next time rain hits your window, look closer. You may be witnessing invisible engineering at work. A silent chemical orchestra cleaning the world. The future might not always look futuristic. Sometimes it simply looks perfectly clean.